on. Beautiful. All right. Okay, here are the answers to the homework. Come on. It is really temperamental here. Must be. It's like everything is delayed. Hopefully it'll catch itself up and won't be an issue, but we'll see. But it's really, everything's slow. Yep. All right, number one. Number one is the point -147. -147. I'm frozen. Okay. By the way, the answer was 36 if anybody did it. X was 18, so 2 times 18 is 36. All right, number 3 is the point 82 -4. 82 -4. Number 4 is the point 16 -2. 16 -2. Is 6 the next one? 8. I don't know why it's doing that. Okay. Number 8 is 6/2 -3. 6/2 -3. Number 10, 1/3 -1. I'm sorry, 1/3 -1. 1/3 -1. 21 is the square root of 41. And 23 is x equals 5/2 and x equals -3/8. X equals 5/2, x equals -3/8. Number incorrect top. Pass those back to the owner, please. Morning, guys. Go ahead and just grade your own homework, okay? All the answers are right up on the board for you. All right, what can I help you to understand? Morning, Dawson. Just go ahead and grade your own. The answers are up on the board. What can I help you with? Any of these? Anybody? Danielle? Okay, so I'm going to do it your way, Danielle. So let's make sure you had the original correct. X minus y minus z equals -3 is one of them. 2x plus y minus 6z equals 20 is a second of them. And x minus 2y plus z equals 13 is a third. You have the 3 correct? -13. And Danielle, what was your actual answer for 4? What did you get? Okay, did you get the 6 first? Is that the first thing you got? Okay. All right, so you tell me which 2 groups of 2 did you form? Okay. Okay, so you grouped them, I think, like that. Is that right? Okay, so now we got to look at. Is that right? Okay. All right, and you said the second group first. So what variable are you trying to get rid of? X, Y, or Z? X. Okay. So what did you multiply the second equation by? Yeah, because you did these first, right? Okay, so let's check and make sure that your new green is good. So that would be negative 2x plus 4y minus 2z equals 26. So far, so good? All right, when you add them, so that is a 5y. Oh, I'm looking at the wrong place. Yeah, get rid of that so I'm not even looking at it. 5y minus 8z equals 46. Okay. What did you do on the second group? Okay, and that's good. So your new blue is negative x plus y plus z equals 3. And when you added these, did you get negative y plus 2z equals 16? So it's, what's that? Negative 13. Yeah, I see that negative. Twice got me. So negative 10, Daniel? Okay. So now when you put these two together, do you try to get rid of y or z? So did you multiply this one over here by a 5? Okay, so that one's now going to become negative 5y plus 10z equals negative 50. And when you add them, you should get 2z equals negative 4. And z is negative 2. Did you get negative 2 for z? I didn't hear you say negative 2. Okay, so what was your answer again? Okay, so you got your z correct. When you solve for y, you got it correct as well. So you made a mistake when you put z negative 2 and y 6 back into whatever original. So which original did you put these back into to solve for x? Okay, so you should have gotten this, Danielle. X minus y minus z equals negative 3. And y was a 6 and z was a negative 2. So maybe the minus got you? So it should have been x minus 6 plus 2 equals negative 3, x minus 4 equals negative 3, x equals 1. So you may have gotten all the way to the last step and made your mistake on the last step, which is possible. All right, so hopefully that was a primer in the methodology, right? Each one of these a little bit different. Those of you that graded your own, please put at the top of your paper, graded by me, so I know. I just need to look at yours more carefully, make sure that everything's copacetic. All right, I can probably do one more. Anything else? Anybody else? Any other questions about anything? Anybody? Questions? Anybody? Okay, pass those up. Okay, so matrix products, and these are also called dot products. So we've done scalar multiplication already. And scalar multiplication is just a number times a matrix. This is a little bit different. In this one, you have to learn the pattern. And so the pattern basically is this concept: across and down. So you just got to get in your mind across and down. Again, I'm not sure we've covered this before. If we have, let me know and I'll go a little quicker. All right, so let me show you what I mean. Best way to do these is by example. All right, so let's go first row, and I'm going to do it in red. And use your color here to help you to figure out what we did. Let's go 1, 2 in red. Then in the bottom row, let's go black. Let's go 3, 4. All right, that's the first matrix. And then a raised dot, hence we're multiplying them, dot product. All right, let's make the second matrix. This one we're going to do it column by column, okay? So do the first column, 1, 2. Go for green for your second column, go 3, 4. And I'm just going to go back to blue for the third column, go 5, 6. Okay, I also want you guys to take note of the dimensions of the matrices because they have to be a specific, there has to be a specific scenario for you to be able to multiply them. So the first one is a 2 by 2, right? Remember always rows and columns, right? 2 rows by 2 columns. The second matrix is a 2 by 3, 2 rows by 3 columns. For you to be able to multiply matrices, these must match. They have to. So again, just a reminder, this is row, column. This is row, column. So there must be the same amount of columns of the first matrix as rows for the second matrix. Okay? Those have to match. If they don't match, you can't multiply. You can't do the dot product. All right? So you need the same amount, otherwise you can't do it. All right, what's it going to equal? How do you do the multiplication? Use your color here, and it's going to make life a little bit easier. Okay, I'm in red. Right now, remember, the thought is across and down. Across the first matrix, down the second matrix. Across the first and down the second. So you can see across the first is the 1, then the 2. Down the second matrix starts off, if you go left to right like we do, is the 1, then the 2. So this top left number is going to be an addition of 2 things. So again, we're going across and down. Start with the 1 top left, right? Multiply it times, go with your blue, the 1 in the first column of the second one. Okay? So I just multiplied, don't put this in your notes, this times that, right? I'm heading across. Now I have to add to this, and I should have gotten rid of, let me get rid of my circles here. Okay, I have to add to this now the second part of the across, the 2. But I'm going across and down, right? So this red 2 is going to be times the blue 2 as I work my way down the second one. That's going to be the top left number. I went across the left matrix top row and down the column. That's going to be the first number in the top left. Now I got to go to the second column in that second matrix and do the exact same thing. Across and now down the second row. Okay? So this is a cross row 1, down column 1. Now we're going to go across row 1, down column 2. And then we're going to go across row 1 and down column 3. Across and down. So the second set, again, I'm working across, so I'm at the 1 again still. It's like distributing. And this time it's going to be times the green 3, right? I'm working off the middle column now, right? And I'm in the middle column, aren't I? plus across, I'm back to the left, the 2, times down the column is the, say it if you know it, the 2 times the 4. And that's the second top number. Now again, we're going to work across and down the third column. So I'm going to multiply again the 1 times what? Say it if you know it. 5, right? And the 5's a blue 5. And across, so the 2 times the what? 2 times the 6. That's the top row. We went across and down. We went across the top, the left one, and down the first column, across the left one and down the second column, across the left one and down the third column. So what would logically come next? Now we got to do the bottom row of the first one, and we're still working across and down. So bottom row of the first times column 1 of the second, bottom row of the first times column 2 of the second, bottom row of the first times column 3 of the second. All right, so what would be the first number? 3 times 1. And again, we're switching colors a million times here, but oh well. When we do this on the first one. And then what would be the next numbers? What times what? 4 times 2, right? Across and down. Alex, once you get settled in, I'll take your homework. This is as far as we've gotten so far. Okay, so we went across and down column 1. Go across and down column 2. Go across and down column 3. See if you can do it. If you want to look up, that's fine, look up, but see if you can do it. You stick it on my desk. So across and down, 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 across and down. So then you got to figure everything out from here, get all your values. So 1 and 4 is 5. 3 and 8 is 11. 5 and 12 is 17. 3 and 8 is 11. 9 and 16 is 25. 15 and 24 is 39. And that is the dot product. Working across and down. Across each row times each column. First column gives you the first number. Across the top row and down the second column gives you the second number. Across the top row and down the third column gives you the third top number. Across the bottom row and down the first column gives you the first bottom number. Across the bottom row and down the middle row gives you the second middle number. And across the bottom row down the third column gives you the third middle number. Notice the dimensions of the resulting matrix. What are the dimensions of our product here? What is it? A what by what? It is a 2 by 3. Notice this. That will always be the case. That will always be the case. So remember, the rows of the first have to, the columns of the first has to match the rows of the second. Otherwise, you can't multiply them, right? That's this part right here. And the resulting matrix will always be the rows of the first and the columns of the second. Always. Okay? Always. Always, 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 always. Across and down. Across and down. Across and down. Okay? We better do another one. All right, number 3. I don't want to make these too big, so let's start with another 2 by 2. Let's go, we'll stick with 1, 2 on the top row and 3, 4 in the bottom row. That'll make life easier. Now this next one, this is a 2 by 2. 2 rows, 2 columns. So this next one, excuse me, has to have 2 rows, right? It has to. Otherwise, you can't multiply it. All right, so let's go this. Let's go -1, 0, 2, 3. And again, I got to have 2 rows. So let's go 1, 2, -2, 0. All right, so remember, you got to work across and down. So before we get started, we got a 2 by 2, and we've got a 2 by 4. Agreed? 2 by 2, 2 by 4, right? So what are you expecting your resulting matrix to be? A what? 2 by 4. You have to end up with a 2 by 4. You have to. Okay? See what you can do. I'm going to be putting it up on the board. So I'm not gonna freeze the board. I'm gonna be putting it up there. So anywhere along the way, if you want, look up at the board to if you're concerned about whether you're getting it right. I don't have enough room to the right, so I'm going to start underneath. Okay? But see if you can do it. And if you need help, look up at the board for help. Be careful with your positives and negatives now because we have a few of those. Thinking across and down. Across and down. Working across and down. Across and down. Across and down. Across and down. If you don't end up with a 2 by 4, you did something wrong, right? Let me throw this out here to you. Some like to do it this way. Let me just show you something. You don't need to do this in your notes. But some would like to, because they're going across and down, they like to just set it up. right? And so then where am I going down? All right, and I'm sorry, backwards, cross and down, right? And then -1 plus 1, -1 plus 1, -1 plus 1, and they're working their way across and down, and what did I just do? I missed one, all right? So a fourth one. And I just blew that whole thing. Let's go back. Cross and down, you got to go across and down, across and down, across and down, 4. So, but some like to do that. Your mind might work that way. Hey, I know all the tops are going to be a 1 first number, 2 second number, and I'll set up all 4 across. Just got to be careful you don't do what I just did, hit all your columns down. Again, your mind may work that way. My mind works better this way. In either case, you need to be careful. Questions, 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 questions. Anybody? Questions? Okay, so that's matrix multiplication or dot products. I am going to give you the work off of these. As you know, there's only a few always from matrices, so this is 1 through 5. If I remember correctly, one of these won't even be able to multiply. And they won't be able to multiply because the columns of the first will not match the rows of the second. So what would you say in that case? You'd say no solution, right? So if I'm remembering right, it's been a year since I looked at the homework, but if I'm remembering right, one of them will not multiply. And all of these are not multiplication problems. Some of them ask you what would be the resulting matrix. Okay, I have 10 minutes left. I need to take it. This homework's not going to take you long tonight. It really shouldn't unless you're having a problem with the pattern. And I need to be careful and get you ready for tomorrow's quiz and Thursday's test. So as I told you guys before you left for the break, be careful because when we come back, we're going to have a test, and indeed, we're going to have a test. Look, this concept is the key to everything, right? In being able to solve word problems. So what do you want? When possible, make a chart. What tells you how the chart goes? The formula, right? The formula determines the columns of the chart. A good tip that helps: fill in the variables first. Always put them in first. The problem tells you what it's looking for. Is it looking for rate? Okay, put the variables in the rate column. Is it looking for the time? Put the variables in the time column. Is it looking for a principal? Put the variables in the principal column. Put the variables in first in your chart. Where will the equations come from? The columns that have the variables. So those are going to be your equations. There are 2 possible equations to write. A total equation, which is always this template, right? First plus second equals total. Or the comparison equation, where the first is compared to the second, but you got to go back to the original problem and look at how they compare and use that comparison by either adding it or subtracting it to one of the sides to make the 2 equal. And remember, I gave you a tip. If you're not sure what to do, just make up a number and then see where you'd put that extra number. So that caused us to do this. There's the formula. Gave us the columns of our chart. We labeled the rows, car 1, car 2. We filled in the variable column first. Time was 1. This is another place where you guys make mistakes. You look up here and you see 100 miles and you want to put 100 and 100, and that's not true. The distance is the rate times the time. 1 times x times 1 is 1x. The rate times the time, y times 1 is 1y. Now we have a rate equation, the variable column, and we have a distance equation, variable column. I did distance first, Is it a total or is it a comparison? I look at the thing. They're 100 miles apart. They head toward each other. What's the distance? It's a result of adding up this car's distance and that car's distance. It's a total. Besides, it doesn't tell you like the one car traveled 30 miles longer than the other car. The one car went 50 miles less than the second car. That's a comparison. 100 miles apart, that's a total. So that was the comparison equation. First plus second equals the total. What's the first? Distance, x. I'm doing a distance equation. What's the distance of the second? Y equals the total distance, 100. Rate equation. All right, got to look back. 4 miles an hour faster. Ah, that's a comparison. First equals second. And then you got to figure out, and first car, second. I put down here faster, right? Because it said the second car was going faster. Look, if something's going faster, do I want to add more to it? It makes it even more unequal than the other. If this is faster than that, I got to take away that amount to even them up, or add this amount to the other side, right, to even them up. So you're going to have to do that tomorrow on the quiz, and you have to do that on the test on Thursday. You're going to have to do this. Now, you can choose not to, but I'm telling you, that's like 4 questions right there, besides then the answer. So you need to know how to do it. Secondly, we did interest problems. You got to know the formula, principal times rate times time equals interest. Same principles. The formula gives you the columns of your chart. Label your rows. Fill in the variable column first. Go to the problem. Be careful with your rates, guys. Percentages have to be in decimal form. 7% is 0.07. 12% 0.12. 10% 0.1. 3% 0.03. 4.5% 0.045. Be careful with your percents. Time, this one happens to be 1, could be 2 years, could be 3 years. How do you get the interest? Principal times rate times time. How do you get the interest? Principal times rate times time equals the interest. Where do your equations come from? The columns with the variables in them. See, same things we're doing over and over again. All right, let's start with the principal column. Look at the principal. What does it say about the principal? John invests so much in an account, 10% interest rate, and 100 less in an account that yields 12%. 100 less. Is that a total or is that a comparison? It's a comparison, 100 less. Do your comparison template. I wrote, this is the less one. What do you do to make things equal? Add to the one that's the least, or take away from the one that's the biggest. By me saying this is the less one, I know what to do with the 100. Not hard. Go to the interest equation, variable column. Template, total. Plus plus equals total, right? Because it said annual interest of 605. Again, what is the interest of the first? 0.1x. Interest of the second, 0.12y equals the total. And then don't forget at that point you got to solve by either substitution or elimination if you're going all the way to solving. Digit problems, I'll just tell you right now, I won't put one on the test. So just so you know. Be careful because we've done other things, solutions, the quad systems, the point of intersections. You got to find those point of intersections graphically, and you also have to do it algebraically, right? By elimination or by addition, or substitution. Don't forget minors. I think that's next. Oh, linear programming. Feasible region, right? Hey, all that is a bunch of inequalities where you shade the solution, right? That's the feasible region, the shaded solution of inequalities. Take the corner points and either maximize the objective function or minimize the objective function. That was the quiz. Minors are in there somewhere as well. Right there, matrix minors. Hey, remember the plus minus factor only comes into play in the row or column that you're finding the minors of. But be careful, you're going to have that on the test on Thursday and perhaps on tomorrow's quiz. Don't forget things like consistent independent, inconsistent, consistent dependent. Don't forget how to solve graphically a system of equations. Don't forget how to solve graphically a system of equations that are a system of inequalities. Trying to think what else is on there. That's basically the test. Better be careful. Got today and tomorrow to get yourself ready. Any questions?